Hey guys, welcome to AI with AI. So today's video is all about how to apply machine learning. A very basic question that I generally get around, that how can I really get started with machine learning, and how can we set up our Python environment to get ahead and get started with machine learning. So let's discover how to apply machine learning and how to set up a Python machine learning development environment using Anaconda. So let's talk about first part of this video, that is how to apply machine learning. There are three ways by which I can really get started with machine learning. The first one is the libraries. The second way by which I can apply machine learning is cloud. And the third way is using web services. The very first way by which we can start using machine learning is a web service, where we get the ready-made models, ready-made application, a software as a service. So here you can embed the existing application or a model into your application so that you can just use the ready-made model which has been provided by different service providers. But I really feel there is no learning in web services. It's as good as you have a ready-made model along with the trained data, and you just have to use that ready-made model and embed that into your application, and you get application running right there on your phone, right there on your existing application, and you can make your application AI enabled. So if you need a generic models, you can think of using web services. Generic, I mean to say where you have no specific requirement, because the models are already trained, they are pre-trained on their data, and hence you may not get the accuracy or the result which you require for your specific data, for your specific application. So in short, this is ready-made, there is less customization. Whereas in case of cloud, we have some flexibility. We can tweak the model, we can customize the model, we can modify the model as per our requirement. Though the algorithms are already predefined, we can provide our own data and we can tune the model as per our requirement. So you have some flexibility in the cloud because you can provide the data to the model, and based on your data, the model will be trained. So there are chances, if you provide neat, clean data, and if you provide a quality data along with some feature engineering, along with tuning the parameters, you'll have better accuracy than web services here. Whereas again, the model is pre-created, but the difference is in web services, the model is trained on the data provided by the vendor itself. Whereas in cloud, you provide the data, you clean the data, you do the feature extraction, feature engineering, and whatnot, and based on that your model will be trained. And that's why we are saying that in case of cloud, you may have a better accuracy than the web services. Going further, the third way of applying machine learning is using libraries. So you use the libraries, you create the machine learning model from the scratch with the help of a very basic machine learning library, that is scikit-learn, or you can use any other libraries or tools that you want, maybe a Theano, or maybe Theano is not used nowadays, a TensorFlow, you can use PyTorch, NumPy, Matplotlib, SciPy. There are n number of libraries that you can think of using, and you can create your own model. So this model will be created from the scratch, but definitely there are some pros and cons in each way whenever you think of applying machine learning. So definitely there is a learning curve in the libraries. If you go for libraries, you'll have to start from the scratch. You decide the data, you decide the model, you decide the algorithm, you do the feature extraction, you tweak the parameters, and you improve the accuracy over the time slowly. And hence the libraries are better if you want to create your model from the scratch. When I say model is nothing but a machine learning application. Alright, so there are pros and cons of each type that we have here. So in case of web services, if you have less time and you have a lot of money to spend, you can directly get started with web services. You can take the model pre-defined, pre-ready, trained on their data. You can take that and embed in your application, and your machine learning smart application is ready. Whereas in cloud, you get some flexibility if you want to train your model based on your data, and you may want to do the hyperparameter configurations, and based on that, if you want to improve the accuracy, you can think of using cloud. Whereas in case of libraries, you have lot of time and you don't have money, and you want to start it from the scratch, and you also want to become a master in machine learning, and you may want to do your own research, then libraries is the best way to apply your machine learning techniques. Let's see one by one from right to left. Let's start with web services. If you think of using web services, you have money and you have less time, and you just need to make a mature application, predefined application, a more smarter, then you can definitely go for web services. There are many IT giants, those who are providing these machine learning web services over the cloud. A very famous one you might have already heard about is Amazon Web Services, where you can get a machine learning web services as well. Then after that, we have IBM Watson. You might have also heard about this, where we get a lot of predefined models, where you may want to embed a chatbot application, where you may want to embed a text to speech, speech to text, a recommendation. So these kind of applications are already predefined in IBM Watson or any other web services that you see here, right? Then we also have Azure machine learning web services available and provided by Microsoft, right? And not only these, we have some startups which are coming up, those who also provide a really amazing machine learning models, provided if you really have a specific requirement of the application, then these startups may help you better. I will show you a demos how to use these web services, but not now, maybe in some other videos. Currently we are just learning really basics, but first of all we need to know the terminologies and the buzzwords that we generally get around in machine learning. So the second way I told you about is a cloud. So now if you think of using cloud platforms, then we have again many cloud platforms which are available. So these are not only the cloud platforms which we have, okay? There are some more platforms which are providing cloud services to apply machine learning in your application. The most famous one is again Amazon machine learning cloud platform. Then we have Microsoft's Azure, then we have a big ML, and we also have Google Cloud and Google AI, which will help you to create a customized machine learning model based on your data. And the third way that I was discussing about is libraries. And now if you really want to learn machine learning from the scratch, and if you want to be a machine learning engineer, and if you want to do further studies, if you want to be a master in the machine learning, and you want to dive more and learn deep learning and create a specific application to solve a day-to-day life problems, maybe in different areas, say autonomous cars, a text to speech like Siri, OK Google, Amazon's Alexa. If you want to create these kind of applications from the scratch, you have no other way than the libraries. A lot of learning curve, but this is fun, and this is what we are going to learn on this channel. I'll not be talking about the web services, I'll not be talking about the cloud, we'll not be using ready-made models here. We'll be creating our own models, own machine learning application from the scratch. So we'll be taking the help from the libraries that we have here. So you might have already heard about these libraries, a scikit-learn, a TensorFlow, a Pandas, PyTorch, NumPy, Theano, Spark, Keras, NLTK. There are n number of libraries and the tools that we can think of using when you want to learn machine learning from the scratch and create your own model from the scratch. Out of this, to start with, we'll be using NumPy, Pandas, Matplotlib, and then the scikit-learn. And when we start learning a neural network and deep learning, we will be talking about a TensorFlow in detail. And if you still don't know the roadway to learn machine learning, how to get started, and what is the path to learn machine learning, then please stop this video here and watch that video first, where we have discussed about a road to machine learning and what is the learning curve that we have in the machine learning. So I'll keep the link in the description below. And how many of you are really thinking here that we will be creating the algorithms for machine learning? And this is also one of the basic misunderstanding that people get, that they will have to create the algorithms. Are you really going to create the algorithms? No, the algorithms are predefined. The algorithms are already created by the researchers. We will be not creating the algorithms. We will be just using predefined, pre-created algorithms and providing our data to these algorithms. And where are these algorithms? These algorithms are already there in these libraries. So we'll be using these libraries to make use of those algorithms. So definitely we will be not creating the algorithms. We will be using the predefined algorithms here. Now let's dive deep and understand how can we use these libraries and start applying machine learning from the scratch. So there are basically 4 steps that we have here, as you can see, right? So the very first step that we do in machine learning is pre-processing. The second step that we generally follow is the learning. The third step is evaluation, and the fourth is prediction. Let's understand these steps in detail one by one. What is pre-processing? Pre-processing is the first step where we get the data. We divide our data into a training and testing. We divide our data into training and test, maybe into 80-20 ratio, 60-40 ratio, 50-50 ratio, whatever that you want to divide, you decide it, right? Basically, we create a training data set and the testing data set. All right. The data which we receive may be a raw data or the label data. Generally, I have seen people divide it into 80-20 ratio. Then the next step is learning. We take the learning algorithm. That means we decide the algorithm that needs to be used for the data from the libraries that we have thought of using, and what data we provide to this learning algorithm is a training data set, not the testing data set to start with. We provide only training data set to this learning algorithm, and we train our model, and based on the training that we do, we create a model and we test the accuracy of our model. And if the accuracy is not so good, again we tweak this algorithm, we provide hyperparameters, we may do some feature engineering, and based on that we can improve the accuracy further. So the story doesn't end here. Once we are ready with our model trained on the training dataset, now it's a time to test our model on the testing dataset. So now we'll provide testing dataset. The dataset which is not shown before will show this data to the model and will check the accuracy again. So your training accuracy may be more than 90%, but when we provide a new data, test data, where accuracy drastically decreases to say 70 or 80%. So what we have to do again is train the model, tweak the parameters, do the feature engineering, and keep testing our model again and again unless and until we don't get the required accuracy. And once we are happy, then the final step where we provide a complete new data which is not shown before, and that will be our final prediction, final accuracy of the model that we have created. And once you provide the new data, make sure that you don't train it again. Whatever the accuracy or the prediction that you get on the new data, that is your final prediction, that is your final accuracy. That's it. Now let's understand the same thing again, how to apply machine learning with the diagram here. If you look at this diagram, this gives you a complete picture. Definitely the very first thing that we require is the data set. If we don't have a data, we cannot do anything. So quality data is required to create a better and mature model. We take the data, we pre-process the data. In short, we apply some feature engineering, dimensionality reduction. There are some algorithms, there are some techniques that we apply here. That is what the pre-processing. We are going to discuss that one by one in detail, maybe in coming videos. For now, let's just say that it is cleaning of data, and that's what we call as training data. We provide this training data to the machine learning algorithm that we have selected to train on, and this machine learning algorithm will give us a model. Model is an application. So machine learning algorithm will give us a model and not output. Machine learning algorithm gives us the model, right? So once your model is ready, you can say your machine learning application is ready. Now you can provide a test data to this machine learning model, and you can check the prediction, the accuracy. You test the model, and if you feel the accuracy is not the desired accuracy is not so good, again you can tweak the algorithm, configure the hyperparameters, do the feature engineering, and then you can improve the accuracy to create a new model again. And we keep repeating this process unless and until we don't get the desired prediction. That is how we apply machine learning. Alright, that is it for now. Bye bye. Take care. See you in the next video.